Okay, so here's my project folder. I open that up and then go to the bin folder. By the way, bin is short for binary. And here is my executable file. So if I give that a run, and there we go, it doesn't really do anything, but I just wanted to prove to you it works. Now, just to clarify again, there are several good reasons why you should use a language that compiles. One is because you get that optimization in there, making your program run faster and with better performance. The other reason is that I can take this exe file and I can send it to my friends, I can send it to whoever I want, and it will run on their computers. They don't have to have Visual Basic installed. But the third reason for why this is important is because if we open this up in Notepad, we just get a bunch of gibberish, which is a good thing. This gibberish is a good thing. We don't want other people to read our code. So if let's say, for example, we made a video game and we were selling it to somebody, the last thing we want is for somebody else to get our source code for that and steal the idea and rip us off. So obscuring your code in the format of machine code is a good thing. Okay, so moving on to interpreters. Interpreters are pretty much the polar opposite to compilers. They don't make an executable file, which is a bad thing. There are no optimizations, which is also a bad thing, and errors will not be spotted before running. That is a bad thing, although some people think it's a good thing because they're scared of those squiggly lines, but generally speaking, it is a bad thing. What usually confuses students is the bit where I say an interpreter's, oh, bit of a typo there, an interpreter will convert one line of high-level language code at a time. So one line at a time an interpreter does, as opposed to the whole thing. That often confuses students. Let me give you an example. So all of this code gets compiled at once and optimized, all of it, the whole chunk of it. But with an interpreted language, it takes one line each step. And let me show you with an example. And you can do this at home if you want. All you need is a modern web browser. You can do this, you don't have to do it in Firefox. I'm sure Chrome will work. If you're using Edge or Internet Explorer, then how are you watching this video? Okay, so if you go to Inspect Element, and then you go to the console, I'm sure Chrome has a similar feature to this. We can actually start coding in JavaScript right away. So I'll say x equals 42, and look at that, it spits out 42 in response because it's already compiled that one line of code. I've not even finished programming and it's compiling as I go along. So x is equal to 42, and let's make x equal to x times by x. So even though the code has already been compiled, x already exists, it's floating around somewhere in the computer memory. So there we go, there's our answer. And if I wanted to print this out to the computer screen, I can just say alert followed by x. By the way, alert is just the JavaScript version of message box or console.writeline. And there we go, pops out on the screen. But that's what it means by one line at a time. Hello students, and welcome to another GCSE Computer Science Theory lesson on Unit 2, High-Level Languages, Low-Level Languages, and Translators. Grab yourself a cup of coffee for this, because this one might get a little bit boring, as opposed to all the other lessons which have been just a non-stop thrill ride. Okay, so this first one, we're going to be talking about high-level languages. Well, high-level language is the languages you've been using already throughout your GCSE. So Visual Basic is an example, C++, Java, Python, the list goes on. There's hundreds, maybe even thousands of them, maybe. I don't know. I've never really looked it up, to be honest. Maybe you could, if you can be bothered. Yeah, high-level languages are really, really cool things because they are easy to understand. And I say, well, they're easy for humans to understand compared with programming straight up in binary. For those who don't know, everything you do on a computer is fundamentally represented by binary, including what you program in. And Yeah, and programming in binary, never attempt it because it will just give you nightmares. High-level languages are good because, well, they're easier to understand and they're abstractions from binary code. Low-level languages, in contrast to high-level languages, they do include things like coding in binary, although they call it machine code for some reason when it's in binary, and assembly language. And assembly language is this example on the left here. I can't say it's awful that much better than machine code. It's still absolutely horrible to work with. Most programmers cannot code in assembly. Just trust me on that. Most people can't. I won't expect you to do any assembly language coding at GCSE. Even at A level, the amount of assembly language done is not really assembly. It's pretty easy stuff, to be honest with you. But actual assembly language is awful. Just stay away from it. It'll give you nightmares. So yeah, low-level languages include machine code and assembly. Assembly is really difficult for humans to read. Arguably, though, assembly language is easy to read when you compare it with machine code. Okay, you also need to be aware of 3 different types of translator. There are 3 different types: compilers, interpreters, and assemblers. So starting off with compilers. Compilers take all of your high-level language code. So it takes all of your Visual Basic code, for example, and then converts it into machine code, turns it into ones and zeros. When this happens, something called an executable file is made, an exe file on Windows. The code is cleaned up and optimized, which is good. So by the way, making an exe file is a good thing for what I'll explain in a minute. Cleaning up and optimizing your code is good because it's going to run faster. And also errors are spotted before your program is executed. So your compiler has the capacity to spot errors before you waste your time running the code. So I'll give you an example. By the way, this IDE I'm using is called Sharp Develop. If you're not using it, I very much at the least recommend that you give it at least one go. Just give it a little go if you're not using it already. So anyway, here's some fairly pointless code. It doesn't really do anything, but I just want to show you the role that the compiler plays. So if I press this run button, oh look, you'll notice it says compile.exe. So there you go, there's my compiler there. And this hasn't just ran the code for me, it's actually compiled it into ones and zeros. And if you want to see that compiled program, you can go to your project and go to Open Folder in Explorer.